Excellent. So a wireless network is a computer network that uses wireless data connections between network nodes. Wireless networks are generally implemented and administered using radio communication. And with this method, the costly process of introducing cables into a building can, well, obviously be avoided. A wireless local area network, WLAN, links two or more devices over a short distance using a wireless distribution method, usually providing a connection through an access point for internet access. IEEE 802.11 is a set of MAC and physical layer specifications for implementing wireless LAN computer communication. Now, they're the world's most widely used wireless computer networking standards, used in most home and office networks to allow laptops, printers, smartphones to talk to each other and access the internet without being connected to any wires. So for this, I'm just trying to keep it simple, so I won't talk about the entire 802.11 family or the technical details beneath them. I just want to let you know that the most popular are those defined by the 802.11b and the 802.11g protocols, which are amendments to the original standard. So 802.11-1997 was the first wireless networking standard. But 802.11b was the first widely accepted one, followed by 802.11g and then 802.11n. 802.11n is an amendment that improves upon the previous 802.11 standards by adding multiple input, multiple output antennas, MIMT. So MIMT, it's basically a method for multiplying the capacity of a radio link using multiple transmit and receive antennas. Nowadays, 802.11ac is popular. So it builds on the 802.11n and includes wider channels in the 5 gigahertz band. The segment of the radio frequency spectrum used by 802.11 varies pretty much between countries. For example, in the U.S., 802.11a and 802.11g devices may be operated without a license, as allowed in the regulations. Wireless networks are identified using a Service Set Identifier, or SSID, or I'll call it a SID. An SSID is the primary name associated with an 802.11 wireless LAN, including home networks and public hotspots. Client devices use this name to identify and join wireless networks. Now, there are multiple kinds of SSIDs. Used by itself, the term SSID refers to the name of a wireless network, whether it be a point-to-point network made of only individual wireless clients intercommunicating, or an infrastructure network with clients relying on access points. So getting more specific, we have basic SSIDs, or BSSIDs, which are the MAC address of the access point, the 48-bit number that uniquely identifies every wireless, and every wireline for that matter, network interface. The extended SSID, or ESID, is a unique name applied to one or more access points offering the same service, such as access to a single wireline network. Now, in some deployments, unique ESIDs are applied to each individual access point. In others, all access points that offer access to the same wireline network are given identical ESID values to help foster roaming between the various access points. But generally speaking, when analyzing wireless LANs, we want to discover the BSSID, the MAC address, and the ESID, the name applied to the wireless network as a whole, with a unique value typically applied to each individual access point. Now, since this is a course for penetration testers, we really need to talk about the weaknesses of the wireless network infrastructure. So here are some of the most significant vectors for wireless attacks. Denial of service. Blocking legitimate users on a wireless LAN is trivially easy. even if the network is carefully constructed. Rogue access points. Employees sometimes set up unauthorized access points in an enterprise environment to bypass the legitimate wireless infrastructure or to gain wireless access when such an infrastructure isn't provided by the enterprise. Now, penetration testers and ethical hackers alike are sometimes required to sweep an organization's physical infrastructure to find these unauthorized access points. Lack of or improper configuration of wireless access points. Right, so if access points are not configured appropriately, attackers can have a much easier time of employing any of the rest of these attack vectors. Traffic capture intercept. In a wireless LAN, the hacker can get access to the data link layer 2 communications, as long as he or she is in physical proximity of the device. For merely capturing packets, that proximity for a wireless LAN could be a mile or more. Numerous wireless sniffing tools can be used in such attacks. Crypto attacks. Some wireless encryption protocols suffer from significant security weaknesses, such as the Wired Equivalent Privacy (WEP) protocol. Attackers can gather web traffic and, by exploiting flaws in the way cryptographic initialization vectors are exchanged, crack the keys to gain access to the data and the network. Client duping. Some tests call for a penetration tester or ethical hacker to set up a bogus access point to see if clients will trust it and then use it to access the rest of the network. The attacker can then sit in the middle of all the communications, harvesting them or changing the data as it passes by.